Hello everyone. In today's video, we are discussing about the worksheets of our previous video, that is axioms of field. In that, I gave some worksheets in the description. So now I solved the worksheets of the previous video. So let's go with the video. So our first level is proving these 5 questions are closure under addition. So the first question gave 3 plus 7 is integer or not. So we know very well what is integer. Integers are integers are containing 0, plus or minus 1, plus or minus 2, and plus or minus 3, etc. up to infinity. So in that itself, 3 and 7 are there. So 3 is belongs to Z, as well as 7 and 7 is also belongs to Z. So by that, I just add these things, 3 plus 7, I get 10. So 10 is also an integer. So it was there in that. So this implies this is belongs to Z. So this implies 3 plus 7 is also belongs to Z. Okay. So this is satisfied. So our next one is minus 5 and plus 5. So plus 9. So integers are containing the positive values and negative values as well as the non-negative value Z. Sorry, 0. So minus 5 itself, minus 5 is contained in Z, and 9 is also contained in Z. So I can add together. So minus 5 plus 9 equals to 4. 4 is also belongs to Z. So this is also satisfied. So now we are going to the third problem, which is rational numbers. Rational numbers are in the form of P by Q, where Q is not equals to 0. So I just take 1 by 3 and 1 by 2 are both are rational because it's in the form of P by Q. So I just add together 1 by 2 plus 1 by 3. After that I just doing the cross multiplication. So 3 plus 2 and multiply the denominator. So 6. So adding the numerator is 5 divided by 6. So it is also belongs to Q. Why? Because it is in the form of P by Q, and Q is not equal to 0. It's 6. So it's also in the Q. So this is also satisfied. So the next one is something different. Yes, real numbers are contains all the numbers: natural number, whole number, integer, rational, irrational. These all things were contained in real numbers. So our question is root 2 plus root 3 is real or not. So root 2 is an irrational term, number, as well as root 3. But adding this, how can we add? If suppose in the place of root 3 I have a 2, so I add the root 2 plus root 2 equals to 2 root 2. But here root 2 plus root 3. So they are, so I cannot able to add these things since this is an unpaired one, but it is in R. because both are in R, because this is irrational, this is belongs to R, right? So likewise, root 2 plus root 3 is also belongs to R. It means even if it is unlike pairs, they are very special in the real numbers, because I can put the values of root 2 is 1.414, and it's almost similar to 1.6 or something else. So I can get 6 or 5. I can 6 or 5 point extra, it's going on. So I just stopped with the 2 or 3 decimals. So I can get some point value. So it's in the form of irrational terms. So in the decimal form. So it's in the form of decimal points. Decimal points are also contained in real numbers. So this is contained in real numbers. So this is also satisfied. So the next one is 5 plus minus 5, which is belongs to is it. So see here, 5 is an integer and minus 5 is also an integer. So I can add these things, plus minus 5, which is equal to 0. So something which is giving us 0, what we call this as, so here minus 5 is additive inverse of 5. So that's why we can add any number. So any number we can add with some number, we can get 0, that is additive inverse. So here the problem itself is, so this I can add these things, I get 0. 0 is also there in integers, so by that this is satisfied. But the question giving like 5 plus minus 5, so that's why I explained this is an additive inverse of this. So our first level is over with this. So